Algebra 3, Chapter 2, Section 4, a library of parent functions. The first function we're going to examine is the constant function. The constant function is in the form of f of x equals number. So basically it's just a flat horizontal line. The domain will be all real numbers. X can be anything. The range is whatever value f of x is. In this case, the range would be 3. It is even. It is symmetric about the y-axis. It can be odd if f of x equals 0. There are no zeros unless f of x equals 0. It is constant. In other words, it's not going to increase or decrease. It's just going to stay flat the whole time. It has no maxima and no. And then we have the linear function. Now, the constant function, you might be thinking, well, that's linear. Well, not really. It is a line, but it is not considered a linear function. It's considered the constant function. A little weird, but that's how it is. Linear function is going to be on a slant, and we have the most basic one here, y equals x. The domain is all real numbers. The range is also all real numbers. It is an odd function. There is 1, 0 at x equals 0. It is increasing over the entire domain. It has no maxima. It will keep going up forever. And it has no minima because to the left it will keep going down forever. Now we have the squaring function. The most simple squaring function is y equals x squared, and you see it pictured here. The domain is all real numbers. We've seen this before. The range is y is greater than or equal to 0. You don't see any y values being used below that. So the range is y is greater than or equal to 0. It is an even function because it is reflected across the y-axis. It's mirrored across the y-axis. There is a 0 at x equals 0. It is increasing when x is greater than 0. In other words, from 0 to positive infinity, the graph is going up as you look at it from left to right. It is decreasing when x is less than 0, or from negative infinity to 0. It is going down as you look at the graph from left to right, from negative infinity to 0. It does not have any maximum points, but it does have a relative minimum, and that is at the point 0, 0. And now we have the cubing function. You see here the most basic one, y equals x cubed. The domain is all real numbers. The range is also all real numbers. It is an odd function. There is 1, 0 at x equals 0. This function is increasing over the entire domain. It has no maxima values and no minima. The square root function, which is the inverse of the square function. It's y equals the square root of x. This is the most basic one. The domain, x is greater than or equal to 0. Remember, we do not want to have an imaginary root here on our graph, so we don't want a negative number under the square root. The range is also going to be y is greater than or equal to 0. This function is neither odd nor even. You don't see it being reflected or mirrored across the y-axis, and if you turn it upside down, it certainly does not look the same as it does right now. There is 1, 0 at x equals 0. It is increasing over its entire domain. It has no maximum values, but there is a minimum value at 0, 0. This is the reciprocal function. It's kind of hard to see that. That's the function f of x equals 1 over x. The domain is everything but 0. So x cannot be 0, but it can be anything else. The range, well, y can't be 0, but it can be anything else. It is an odd function. It has no intercepts. It does not cross the x or y axis. It is decreasing constantly. If you look at it from left to right, the left-handed branch starts close to 0 and drops down. The right-handed branch starts way up in the, way up where you can't even see, and drops down. So it is decreasing over the entire domain. It has no maxima and no minima. This is the absolute value function. We've looked at it before. The domain is all real numbers. The range, y is greater than or equal to 0. It is an even function. There is one 0 at x equals 0. It is decreasing when x is less than 0. So from negative infinity to 0, as you look from left to right, it is going down. And it is increasing when x is greater than 0. So from 0 to positive infinity, as you look at it from left to right, it is going up. There is no maximum, but there is a minimum at 0, 0. The step function, we're using the greatest integer function to represent that. You see two ways that it can be shown with notation here. Usually we use the lower one. That's the most common one that I've seen. And this is what it looks like. It's called a step function because it looks like a set of steps. The domain is all real numbers. The range is the set of all integers. Notice that you don't have any connection points between the integers. Y can be 0, it can be 1, it can be 2, but it can't be anything in between those numbers. It is neither even nor odd, and you may think that's strange, but if you turn it upside down, it doesn't look the same. Because notice that the left-handed point of each small line is included while the right hand is not. It is 0 between 0 and 1. It is constant between each pair of consecutive integer values of x. It has no maxima and no minima. Now, in case you're wondering what the greatest integer function is, the simplest way to explain it is that it's a function that rounds everything down. So if you have a whole number or an integer, it equals the integer. But if you have something like 2.4, it's going to round it down to 2. If you have 2.6, it's going to round that down to 2. So everything gets rounded down to the nearest integer for this function. And we're also going to talk about graphing a piecewise function here. A piecewise function is defined in pieces. So when you're graphing by hand, you're just going to graph each piece separately. So here we have the function 2x plus 3 when x is less than or equal to 1, and negative x plus 4 when x is greater than 1. Now, why don't you pause the recording and see if you can graph this, and then resume it to check your answer. But like I said, what you want to do is you want to graph the 2x plus 3 for all the x's up to 1, and then you're going to graph the rest of the graph using negative x plus 4. Pause the recording to try this and resume it to check your answer. Okay, the green line here is the 2x plus 3, and we graph that all the way up to 1, and then from 1 on we graph negative x plus 4. Now I did use the 1 as a starting point for the second graph, but notice I put an open circle there indicating that that value is not actually part of the graph, it's just the starting point. Again, all you need to do is graph the first line up to 1, including 1, and then graph the second line from 1 on. You can also use your calculator to graph piecewise functions, and here's how you do it. You go to y equals. For y1, you're going to enter 2x plus 3 in parentheses, and then in parentheses next to it, x is less than or equal to 1. Now you can find the less than or equal to, the greater than, less than, all of these if you hit second and then math. You'll notice that in the second color it says above the math key test. That's where you can find all of these functions. So you're going to put the 2x plus 3 in parentheses, the x is less than or equal to 1 in parentheses, and then a plus, and then negative x plus 4 in parentheses right next to x is greater than 1 in parentheses. And then you hit graph and adjust as you need to. Now, we're going to write a linear function such that it has the indicated function values and sketch the graph of the function. Now, they're giving you 2 points, basically. Remember, the number in parentheses is the x value, and the number after the equals is the y. You already know how to write a linear equation or linear function. So, pause the recording, give this a try, and resume the recording to check your answer. So the points we have are 1, 4, and 0, 6. Using our slope formula, we get negative 2 for the slope. And then the easiest point to put into point slope form would be the 0, 6. So we put that in and we get y equals negative 2x plus 6, which means our function is f of x equals negative 2x plus 6. And there's the graph of the function. Now use the graphing utility to graph the function, and then sketch what you see. Pause the recording, give this a try, and resume the recording to check your answer. And there we have the cube function. Notice it's been moved down 1. That's what the minus 1 is doing to it. We're going to talk about transformations in another section and see how we go from the original function, the x cubed, to the x cubed minus 1, and exactly what all the numbers do to the function itself. Now try this graph. Again, use your calculator, graph it, and sketch what you see. Pause the recording and then resume it to check your answer. Okay, your graph should look something like this. Now you're going to evaluate the function at the indicated values. Notice we have the greatest integer function here. Remember what I said? The greatest integer function rounds everything down. So you'll put each number in for x, and then whatever you get, you'll round down to the nearest integer. Pause the recording, try these out, and resume to check your answer. For A, you should have gotten 8. For B, 2. C, 6, and D, 13. Now you're going to sketch the graph of this function. You can do this by hand, or you can use the greatest integer function that's built into your calculator. If you go to the Math menu, and then go over to Number, it's number 5 in that menu. It says INT, and then open parentheses. Pause the recording, give this a try, and resume the recording to check your answer. And this is what your graph should look like. Now try the graph of this piecewise function. Pause the recording, give it a go, and resume the recording to check your answer. Okay, it kind of looks like a little frog jumping here. This is what the graph should look like. And notice that we're actually connecting there at 2. For both of the equations, when you put in x equals 2, you get 0 for your answer. So the graphs actually meet, and there's no break there in the continuity.